Okay, so the next force that we actually talk about is actually what we call your frictional force, or in most common terms, we actually just call it friction. Now, why I tend to use the word frictional force more often is because when we say the word frictional force, basically this actually also includes air resistance as well. So sometimes if you're not too sure whether it is the friction of the floor or is it air resistance due to the air around us, you should actually just use the word frictional force because it's actually more generic and you can actually cover both grounds. Okay, so for friction itself, there's actually two different types, but this one is more of a good to know. You don't need to really like go too much into detail itself. So the thing is, for friction, there's actually two different types, static and kinetic. Static means not moving, and kinetic means moving. So first thing, if you all recall back a few the videos before, right? There was one, this one. This box, when you're at rest, now typically when we actually don't move, by right, there should be no friction acting on your object. So like for example, if your box was just sitting here, for example, your box, let's draw our favorite box. If your box is just sitting on the surface, it will have weight and it will have normal contact force, correct? So normally, there should not be any kind of friction. But if your object was sitting on a slope and your weight is downwards and your normal contact force is like this. So what happens is that this weight will actually cause your box to slide downwards. So if there is no friction, what happens is that this box will actually slide down. It will move downwards. So for this box to remain stationary or at rest, there must actually be what we call your static friction. Okay? So basically, as long as you want to balance or basically have no resultant force, you need an extra upward static force, static friction, sorry, it's not static force, static friction itself, so that it will actually not move. It is just to balance it up to a zero. So most of the time, your static friction is kind of good. It actually allows us to do a few things. Is grip onto objects and not sleep when you're walking. So very important is that you need to say not sleeping. Okay, and then it also allows trolley wheels to turn. Okay. On the other hand, your kinetic friction is the one that we are more familiar with. As long as you have any kind of motion, whether it's with the air or with the ground or whatsoever, as long as you have a contact surface area, you will always have kinetic friction. So the thing is, kinetic friction itself will always be affected when you are based off your speed. Okay. So typically, as speed of object increases, friction forces increases. Okay, they should have the same effect. So if one increase, the other also increase as well. So to take note of this, did I spelled it wrongly? Sure. Yes. Okay. So the thing is, now normally when you see a rough surface and you know, let's say they tell you, okay, friction is 4 newtons. So we always gonna assume that they don't change. Okay. If it's 4 newtons, it'll always be 4 newtons, even if the object is like speeding up or slowing down. Typically, this speeding up or slowing down itself is mostly for air resistance itself. For your friction that we have on the ground, usually we use a fixed number, even though in reality, it is not really fixed. It will actually increase as well. But for convenience sake, for us to actually calculate things properly, we'll just assume that they will remain constant. Okay? So let's take a look at the work example below here. Now, typically, let's talk about your positive and or negative of friction itself. Now, between tires and the road. First thing, when you have a tire, when you have a tire itself. Now, let's say the car, like the car below here. Let's take a look at the one below first. If your car is moving to the left, what happens? It means that my wheels must be moving in an anti-clockwise direction. It should move like this. So the thing is, friction is a contact force, which means you need your contact surface area. So if you notice the contact surface area with the ground, my wheel is actually moving backwards. This means my friction, which is always opposite direction, will actually be forward. Can you see that? So because of this, the wheel, when it's rotating like this, what happens is friction will actually push it in the direction of motion. Okay, so actually wheels allows us to move faster. So friction allows the wheels to grip the ground and move the car forward. So this is your advantage. Over here, I'm gonna just move the picture across. Okay, I'm just gonna move it up here. Okay, so friction allows us to grip on this one, but basically most of the time you will have some form of negative effect, which is actually what we call wear and tear. Okay, so you actually wear out the wheel, so you actually need to replace your wheels more often. And your brake pads itself, they actually increase friction to stop the car. Okay, so you actually increase the friction to stop the car. So for more details, let's take a look at this. It actually lets the car move forward. Okay, so this one is actually this word means speed up. Okay, which is actually same thing as it basically allows the car to, or the wheel to turn actually. And you will produce wear and tear, which is what I covered. And you can allow it to slow down, which is come to a stop. So same issue as what I actually mentioned here, just that wear and tear is actually for both of these as well. So basically this is your disadvantage and these two are your advantages over here. Okay. Right. So for more details about your advantage and disadvantage and how do we increase and decrease friction, we'll take a look at the next page. First thing, friction always stops you. Okay, it always opposes your motion and it will reduce your resultant force. So resultant force is your total force, right? So if you think about it, this is your forward force. You will plus a negative frictional force. So what happens is basically the more negative frictional force you have, you need more force to actually do a certain action. So if you want to have a lot more frictional force, you will need more to overcome this that increase. Okay, so just be careful. So you need a larger force to do whatever that you want to achieve. So if you want to run faster, there will be more air resistance. So you need to use more strength to run even faster. So because of that, you will basically have a lot of problem. So just scratch out this one. We will use the word heat, not heat energy, or you can just say thermal energy. Okay. So just be careful. Usually when you have work done against friction itself, basically will waste energy. Because you need to overcome your friction, you actually need to spend some energy to overcome this friction. So basically these two are kind of the same thing, just that one is using force to explain and the other is using energy to explain. Okay? And don't forget, you want to say unwanted heat. If you only say heat, sometimes heat can be a good thing because if you are feeling very, very cold, you can rub your hands to produce heat. So you need to see that this is a disadvantage. So we need to say this is unwanted heat. You can also say unwanted sound as well. Okay. So wear and tear, basically wear and tear always basically needs you to spend more money to replace it because you actually wear down or damage. Okay, get damaged. So kind of like the bottom of your shoes and your socks. Some of you, if you keep wearing the same pair of socks over and over again, what happens is that your socks might actually have a hole. So you can actually put your toe through your hole or something like that. Or your shoes, some of your shoes, right, if you notice the bottom, so once you keep wearing the same pair of shoes, sometimes the bottom, the pattern actually gets worn out. And when it gets worn out, you actually have less friction. So sometimes your shoes become actually very slippery. So it's actually not a very good thing. So reducing friction, because of all the disadvantages, you want to reduce your friction. So if you think about it, when you have a car, or a trolley, for example. First things first is that the surface area with the ground, if you actually zoom in all the way into here, is actually very small. It's just this point, this small little point over here. Okay, because a wheel itself, right, is so big, but the point that it only touches with the ground is actually just this part over here, just this small little part over here. Okay, so because of that, you actually have a very small contact surface area. Let me just type it out. Small contact surface area. Okay. So basically, small contact surface area, you will have less friction. Okay. So because of that, you actually have this. Ball bearings work in the same way. Ball bearings are actually little metal balls. So if you actually open up, so for example, your fidget spinner kind of looks like this, right? I don't know how to draw one. But basically, if you open the center part out, if you open the cap, you'll notice that this is actually made of many, many metal balls rotated in a circle. So basically, it works in the same way as your wheel, just that you have two surfaces, one on top, one below, and your ball bearings itself are sandwiched in between them. So same thing, you only have a small contact surface area on top and below. So because of that, you have small surface area, you will actually have less frictional force experience. So since you have less frictional force, you will actually need less energy to overcome all the forces friction that you have. So lubricants is another way that you can reduce friction. Basically, it allows it to slide over one another more easily. So your oil, your grease, it can be water. That's why typically at swimming pools, they usually have the wet floor sign and they'll tell you, floor is wet, please do not run. That is why normally if you run at the swimming pool, it's actually very, very dangerous because you will actually slide down and fall down. So very, very dangerous. Now, air cushions are basically the same thing. It's also a form of lubricant, but instead of using a liquid like oil and grease, you actually use air. So what happens is, this one is a very common one. You have maglev trains. Basically, they're floating above this, where your magnetic force minus your weight is zero, because you're actually floating above. You are not moving, you're not moving up, you're not moving down. These two forces are actually the same. For your hovercraft is just a vehicle that sits on top of water. So when you actually activate the device, you actually float on top of water itself. And you can also search up air hockey. So for those who actually goes to arcades, there are the air hockeys. So before you put in the coin, to activate the machine, basically there is no air that is being produced. But once you tap your card or you pay the money, basically you will hear the gush of air coming out. That's actually producing a layer of air between the hockey and the table itself. So you actually form a air cushion. That's why normally when you're playing the game itself, it's very easy to hit the puck. But once time is up, you hear that the machine comes down, right? And if you haven't finished the game, you'll notice that the puck is on the table. So if you try to hit the puck, you actually it's very, very difficult to actually move the puck because there's no more air cushion in between. So it will actually be harder. So this is actually your air cushion. And your streamlined body shape. If you notice your fish, they're actually in a very nice streamlined body shape, kind of like this. Okay, so the tails are a little bit sharper. So what happens is that for fishes, right, there's actually water resistance. So because of their streamlined body shape itself, they only have a very small contact surface area, and therefore they experience less water resistance. Okay, so similarly for bullet trains, for race cars, all of them have a very, very specific design that looks kind of like a sharpened beak, like that. So basically, they actually want the air to actually just move away, and actually they only collide with a small surface area in front so that you actually have less frictional forces. So including air resistance or water resistance itself. So sometimes if you look at the Olympics, your cyclists, will actually bend forward and lean forward because they actually want to reduce their contact surface area with the air around them. Okay, so that is all for your friction.